for a reason. And the reason I chose this one, it's not that hard, but it's a little busy. Now, first, could you recognize it for me in terms of a vocabulary word? What type of equation should this be? Linear. I'm expecting only one answer for this mess. So I've got to clean this mess up to get that one answer. Now, be careful. I got 8x subtract, now look at this. I know it says subtract 5 times 2x plus 1. Could I maybe think of this as a distributive property and distribute the -5 inside the parentheses? Be careful with the signs and end up with a negative 10x minus 5. Still got this. Just try to clean this up, which sometimes can be much harder than it looks. At this point, I see on the left-hand side, I see like terms. 8x subtract 10x can be put together. That's a negative 2x. Subtract 5. Still got this. Very, very patient with this. Now, at this point, someone tell me, what would you suggest at this point, because we're near the end of trying to find the answer. What did you do? Just give me an idea, just in words, what would you suggest I do? Go for it.
Isolate x.
Okay, you got to isolate x, and to isolate x, you might want to do what?
Add 10 to both sides.
Get the x's on one side together?
Yeah.
Okay, now it's up to you as to which side you want the x's on. Guys, if you move this over by adding, so you're going to end up with 3x plus 2x, that's 5x. If you want to do the same thing with the numbers, move that over there, you're going to end up with a negative 5 plus 10. Is that a 5? Did we move those over correctly? If that's true, the answer is merely divide by 5 there, what? 1. Now, I'm not going to do it tonight, but I've been around long enough where I know my mathematics. I can sit there and do the problem, and all of a sudden get the answer, which we think is the answer, and go back, and it does not check. There are certain equations coming up. In fact, I think I have a couple of these on the handout tonight, that we can do what we're supposed to do. We know what we're doing. We get an answer, but for some reason it will not, when you take them back, will not check. Now, I'm not going to do a full check on this one tonight, but if I go back and put a 1 in right quickly, that becomes what? 2 times 1, 2 plus 1 gives me a 3 inside there, I think, if I replace x by 1. 5 times 3, I guess, is what, 15? So we end up with 1 here also. 8 subtract what, 15? I think it becomes 8 subtract 15 on the left-hand side, negative 7. If I replace x by 1 here on the right-hand side, I get what? 3 subtract 10. Is that also a negative 7?
Yes.
So I can just quickly do that. I know it looks very, very elementary right now, but we had to start class out with this. Part B. Another one to solve here. I brought this one in for a reason. Oh, I see the reason. It's 2 over n subtract 2 is equal to 3 over n plus 5 plus 10 over n squared plus 3n subtract 10. Let me step back, make sure all this copied down correctly. Now, you see that facing you next Wednesday? Something like that. So, whoa, this one's, they're getting a little tougher. Now, can someone tell me, suggest to me what you might want to do first in an attempt to clean this one up, because it's going to be clean. By the way, how many answers might you be expecting, though, when we finish up? The way it looks. 2 answers, 1 answer, 3 answers, how many?
2.
How many answers are you expecting? I'm not saying what is the answer, but how many would you expect, just the way it looks right now, how many would you expect to show up? 2? Okay, right now I see a quadratic in there, maybe we'll get 2. We'll see, sometimes it can be strange. So I got 2, but I see a quadratic involved. You think it might be possible when I finish it up to get a 1? Just 1 answer? Can I get 3 answers?
No.
Okay, so you sort of look at these things, I don't think Professor want to get 3, but maybe 2, I heard 2, and maybe, who knows, something may cancel out on me and just give me 1 for some reason. Now though, I need to clean this up. First, I'm going to get some input from you. the n squared plus 3n subtract 10. Guys, this has to be done. It's got to be factored. Just that part. Here comes your factoring skills. N. Now, can someone help me out? What should I place inside there to make it now in factored form?
-2 and plus.
Okay, I heard -2, was it?
Plus 5.
Plus 5. Thank you. There it is factored. Now, since I changed that to factored form, we lucked out here. Sometimes we don't luck out. Are these actually showing up in the other two terms? Now, can someone suggest at this point, this is beautiful, it's factored. The parts show up also here, which is nice. They match up. Everything's matching up for me. I don't have the answer yet, or two answers. Now what?
Multiply by the other factor.
You mean you want a common denominator?
Yeah.
Now, if you say a common denominator, this one has the n subtract 2. So it's missing the what? N plus 5. So she's saying, Professor, put the n plus 5 in there. Of course, you've got to put it on numerator and denominator. I'm assuming she's going to ask me to do the same thing here. This fraction has an n plus 5. If I want a common denominator, it's missing the n minus 2. So I've got to put that in. Numerator, denominator, and I have that. Now I got to be very, very careful. By the way, are the bottom parts denominators all the way across? Are they the same? At least my denominators. Now on top there, I see 2n plus 10, using the distributive property, equal to, on the other side, see 3n subtract 6. Don't let me mess up, I'm on top of the board here. And of course, on here, just a plus 10. Is that what that comes down to? If they're all over a common denominator, can I just merely say that's it? That takes me to that? All I did was 2n plus 10, distributive property. Here on this side, 3n subtract 6, and then plus 10, I did nothing to that last term, just a plus 10 there. Are you kidding? Is that what it comes down to? If it is, I can clean this up just a little further and call this 2n plus 10 is equal to, looks like 3n, let me put my numbers together on the right-hand side. What is that, guys, plus 4? Negative 6 plus 10?
Yeah.
I can't believe it. Even as much math as I have had, and Mr. Park has had, who would think? Just meet you on campus, and I say, solve this, and it comes out to be this? It was disguised. It looked like a really tough problem. All of a sudden we cleaned it out. It came out to be this. Those kids across the street, the middle school across the street there could do this one. I don't know whether they could take this original in the black, but after you get down to this point here, the middle school kids can solve it. So guys, we'll solve it and find out what's going to happen here. I'm going to just move this over by subtracting. So 3n subtract 2n, of course we end up with n. Subtract 4, 10 subtract 4 is what, 6?
Yeah.
Let's hope I did that correctly. Now, how many answers did I finally end up with? 1. 1. Now, I heard 2 because I do see a quadratic component in the original problem. But could I classify this strange thing in the black here, the original, could I actually classify it as an ax squared plus bx plus c to begin with? No.
Is it irrational?
Okay, it's rational, thank you, it's rational. But I could not classify it as a quadratic. So I do see why you might say, oh, Professor, I see this, so I should get 2 answers. No, actually, when I cleaned it up, it became linear. It was a linear to begin with, just disguised. Now guys, I'm not going to take the answer back to plug it in. I should plug it in and check it and make sure. I thought I'd better bring that in just to point that out. Letter C. Again, from your handout here. Something else I noticed. Oh, I sure did. This one. This one not, I don't think I've done this one yet. Oh, I see why I brought it in. Now, can I right now at this point call this a quadratic? Is this one for sure, not disguised, is it a quadratic? this one was disguised, I had to clean it up. Is this one already cleaned up for me? Is it a quadratic? How many answers would you expect for this one? Definitely 2 on this one. This is a quadratic for sure. It's not messy like this one was. Go for it.
You said C,
Try me again.
which are the problem zone?
Yeah, letter C, was it? Yeah, letter C. It's on your hand, was it on your handout?
I have a different one.
You got a different one here?
Yeah, this one says x cubed equals 16x squared.
Yeah,
Oh, I got you. Oh, for letter C.
yeah.
Yeah.
Yeah, the letters may not correspond. Is this particular problem here on there?
No.
It's not on there? I see why. Okay, guys. Now, what am I gonna do? I'm gonna move that 12 over. I see what you guys are asking. Move the 12 over. Now that definitely is in the what? AX squared plus BX plus C. That's definitely a quadratic. I need 2 answers. I'm hoping it will factor. Now, if someone with strong factoring skills help me out, what does this look like factored?
X
X
minus
plus
6.
6.
Okay, and hand going up, yes.
X plus 6.
X plus 6, X plus 6?
Minus.
Then I heard someone say, no, X minus 6. Is it plus or minus?
Minus.
Okay, I heard minus 6 and X plus what?
2.
Plus 2.
2. Is that it factored? With the factoring skills. Then I heard before the break, we saw something. It says, now, set each one of these factors equal to what? 0? Just a little review tonight. Appreciate this, because things are going to change. Got 6 here. Got a negative 2 here. And for sure, we got 2 answers. This was definitely a quadratic. We place those in a set. 6, negative 2. Okay, this one was not a quadratic that we did earlier. That's the reason I brought it in. My next one looks like this. Let's say letter D. And I think this one's also on your handout. I hope it's on your handout. Looks like this. Solve square root m subtract 1 is equal to m subtract 7. Oh, you guys, is that on the handout?
Yeah,
Yes.
but it's,
Okay.
but it's
Now,
letter E, yeah. E.
it was?
Yeah, it's letter E.
Okay, yeah, I'm gonna call it. Now, any ideas? Oh, by the way, first, is it quadratic? Is it linear? Is it cubic? What is it? Or is it disguised? I don't see an x squared up there. Or in this case, m. I don't see an m squared. Do you guys see an m squared?
It's
Okay,
disguised.
but some of my students say, Professor, I think it's disguised. I think it is a quadratic. What would you suggest I do first to clean it up? Go for it.
I think you should square both sides.
That's exactly what we're going to do. That's exactly what we're going to do. To eliminate that square root, left-hand side's going to be nice. When you square the square root, you really get that. That's so nice. Now when I square this, I guess I get m squared plus 49. Square the m, square the 7. Is it m squared plus 49? I
Yes.
see some heads not. No, it's not. What is m subtract 7 squared? And the reason I said that was many students will call it m squared plus 49. I think it's more than that. What is it?
Minus 14.5.
Okay, m squared, got you. Minus 14m plus 49. M subtract 7 times m subtract 7. Bring back some fond memories. Did you guys have fun back in middle school? Uh-oh. High school? Bring back some fond memories. Yeah, I used to supervise student teachers who planned to be teachers. That was my job at the university. I went out to the local schools and sat in the back and watched a teacher or a student who planned to be a teacher and gave them some advice on how to teach. I saw some strange things being done. Okay, this is beautiful. Oh, by the way, now can you tell me for sure, is this one quadratic?
Yeah.
Definitely, this is quadratic. You're expecting 2 answers. Keep in mind, the original was radical. It contained a radical. I got rid of that radical. Okay, guys, let's move the m over. Try to get one side to be 0. Move this -1 over. I'm gonna get 0 on this side if you don't mind, and end up with m squared. Looks like, here, where am I? Subtract 15m plus 50 as I move things around. That's definitely a quadratic. Now what can I do with the quadratic to finish it up? Factor, if my factoring skills are good, I hope they are. Or use the quadratic formula. Guys, I think to save me a little time here, because we've got some more stuff to do tonight, I think this one will factor. Does anyone have those strong factoring skills? Can you tell me? Yes, sir.
M minus 5, M minus 5.
Love it. M subtract 10, M subtract 5. It tells the professor it's factors. If it does, we've lucked out. I've said each one of these factors equal to 0, and that's why you've got to get 0 here to apply this process I'm doing now. M subtract 5 is equal to 0. You're going to quickly end up with 10 and a 5. Did I get 2 answers with this help? And it wasn't quadratic. After we cleaned it up, I was expecting 2 answers. So we'll place them right here. Is all that making sense? Hang on, hang on. Now, I see right now I've got some good students. Okay, someone tell me, should I, if that were a quiz problem, feel good about it and go on to the next problem and leave what I have right now and go on to the next problem on the quiz and leave my answers like you see now on that particular problem? Because I felt good about this. It factored, didn't it? I got 2 answers. It was a quadratic. Oh, by the way, was the original a quadratic? No. Did I make it turn into a quadratic? Yes. Okay. Give me an idea. Should I go ahead and accept 10 and 5? Because 10 and 5 are the 2 answers for the quadratic. Guys, the quadratic is this. Is this what I originally gave you?
No.
I gave you this in the black. Now the concern is, will those 2 also fit the black? Will they satisfy the black one? I put some things to the black to get down to the red. I may have messed up somewhere. Or they may not check. Okay, so guys, we'll do this for sure. And sometimes on your quizzes, I'll remind you on these types, to make sure you slow down. I'll probably ask you to check it. Guys, let's try 10. I think maybe M is equal to 10. We think M is equal to 10. Go back to the original black. That was the original. Put it in. Replace M by 10. And you end up with this in the original black. Replacing M by 10. I think this becomes square root what? 9? 3. 10 subtract 7. 3. Checks. Now, will the 5 check? Let's go back to the original black. Put that in, the square root of 5 subtract 1. And on the right-hand side, 5 subtract 7. The left-hand side, square root 4, 2. Right-hand side, 5 subtract 7 is -2. Does it check?
No.
No. And all of a sudden you get your quiz back, you've lost a point. You say, oh, professor, you should have reminded me to check. I didn't check both those answers. One of these did not work. I've seen some of these where it takes you half a sheet of paper to do it, and nothing works. You go through, your process looks beautiful. And you get those answers at the bottom there, and neither one of them would check. That may happen. Guys, so here I got to rule out, what was it, 5? So my final answer is merely 10. That will satisfy the original black radical equation. Okay, make sense? Go for it.
I haven't done math in a while, but for A, why would it be positive 5?
You gotta find what we are.
When you put 5 equals 5x,
Oh, you mean right here?
Yeah, because you're subtracting -5.
I'll be a beautiful, because if I look at those x's together, what I actually was doing, I was adding 2x when I say move it over. I was actually doing this. So 3x plus 2x, that's how I got the 5x.
Oh, sorry, alright,
You got me?
Yeah.
Yeah, but do ask, absolutely ask. Make sense, guys? Now, you're gonna be on the alert if you see a square root, go ahead and do this. That's the best we can do, square both sides. But keep in mind, you've changed it somewhat, so you better check these answers. Okay, at least one of these answers in this case did not work. Okay, letter E. I say, Professor, where are you taking me? I'm taking you to some more difficult ones here shortly. Next one looks like this. X cubed is equal to 16x squared. Beautiful. So glad you're here for the first class, just for this little review. Now, how many answers am I expecting, do you think, for sure here? How many? 3. This one's screaming out. You got 3 answers, not 33. 3 answers. Now, I got to come up with some little scheme, some little process of how am I going to get those 3 answers. Can someone tell me what you might suggest I do first? What may help me in the attempt to get those 3 answers on this one? Here's some ideas, and we'll go from there. Go for it.
Would it be possible to rewrite that as x times x squared?
Tell me again now.
Would you be able to rewrite the left side as x times x squared?
Oh, x times x squared. Now get this now. There is nothing wrong with that. That is x cubed. It just so happens it's not going to help me. What you said is perfectly true. It's just not going to help me get to where I want to go. Give me another idea. One's a little strange. We're expecting 3 answers. Let me see. Oh, I see a hand back here. Yes.
Subtract 16x squared on both sides.
Student tells me, Professor, move that 16x squared over. Seems like that 0 on the one side of the equation always helps. I want to get a 0 there. I want to get a 0 there. I want to get a 0. Now, I like that. Now, what are you going to do from there?
Factor.
Factor out like how?
You're gonna do, so you're gonna do x squared on the outside.
Oh, beautiful. She said, wait, is there a common factor of those 2 terms? I mean, something in common right now between those 2? Is x squared in common? Could I pull out an x squared, be very careful, and have this left over? Yes or no? But you got a common factor of x squared. Now, at this point, because that 0 does play such an important part, I'm so glad the student told me to do that. Split this up. Now you're allowed to set this factor equal to 0 and this factor equal to 0. I know and you know. This has got to be 0. X squared is equal to 0, x must be 0. This one, 16. Is that true? Now, how many answers are we expecting? 3. Did I lose one? I see 2 numbers up there, a 0 and a 16. Where's the other one? We're supposed to get 3 zeros. So the quiz next Wednesday, like I said before, if you see a 10, that's your degree, you better get 10 answers before you leave the room. I need 3. I see only 2 numbers. Can someone tell me why is that happening? And let's account for 3. Yes?
Because you can square the answer, like the 0 is a multiplicity of 2. So technically 3 answers, but 2 of them are 0.
Yeah, you tell me right there, x squared is equal to 0, where I say x equals 0. Was x squared equal to 0, was that a little quadratic to begin with? Just itself. Is that a quadratic? X squared. How many answers am I supposed to get just for it? 2. He's saying, Professor, some textbooks will call this a double 0. This is acting as 2 answers. It's a 0, 0. To account for, I'm supposed to get 2 answers. For x squared equals 0, like he's telling me. So that 0 counts as 2 answers. got 0, 0, and then pick up the 16, and I finally have my 3 answers. Now, the textbook will ask you sometimes just list that 0 once, understanding though it actually acts as 2 answers. Then they'll place 16 and close that up. There's a multiple answer. So that 0 is acting as an answer twice. And then I can account for 3 there. Make sense so far? Now, letter E. Try to get all this done so I can ask you to do something for me. Certainly here. I brought this one in, probably from your handout also. Here we go. Oh, here we go. Y to the 4th is equal to 25y squared. I appreciate this first class meeting. Be so happy you're here. Please tell me, the way it looks right now, how many answers are you looking for? 4. I gotta get 4 this time. Now, how am I gonna get those 4? I'm gonna take a suggestion that was given to me earlier on the previous problem. I'm going to save a little time for me here. I'm gonna move that 25y squared over to the other side by subtracting and make it look like that. Try to get that 0 in. Now, strong factoring skills. What can I do with those 2 on the left-hand side? Can I factor some way? Yes.
Take the greatest common factor.
Greatest common factor of what? Y squared? Hang on. She suggested, Professor, to pull out a y squared. If I do and I'm careful, I think everyone in the class would say, Professor, this has got to be a y squared here, and that's to subtract 25 there. Is that true? If I pull out the y squared. Now keep in mind, I'm expecting 4 answers. Now, is there additional factoring required?
Yes.
What is it that we have not really looked at, I don't think, tonight? What is it?
You can still factor y squared and negative 25. It's
You mean y subtract 5 and?
y minus 5, y plus 5.
Love it. Love it. It's called a difference of squares. It factors further. You walk in here next Wednesday and your factoring skills are weak? Don't do that. Don't do that. So if you need some practice on your factoring skills, make sure you get to that math lab. Now guys, can I now split these up, because I got the 0 I need on the other side. And now consider all 3 factors set equal to 0. First one's obvious, 0. Next one, 5. No problem there. Last one is negative 5. Now how many answers was I supposed to get? 4. Did one of those repeat? Like a double 0? Yeah, from right here. So that 0 acts as an answer twice, but they listed only once inside the set. And of course 5 and negative 5, with the understanding that 0 is acting as an answer twice. And those are your answers. Done. A little factoring here. And what else did I do before I jump into something that looks really crazy? Hang on. Maybe it. Hang on just a second. Here. I think it is. Okay. Now, with all that said, I think I've done what I want to do there on this. On the side here, before I ask you to do something for me. Part 2. I want this clever class, and I'm seeing right now I'm going to have a strong class to work with. I want to now take a look at, especially, sort of closing down tonight, these types of equations. keep in mind, they take this form. Now watch carefully, we haven't close this down. You gotta find the 2 zeros for this quadratics. Please tell me, if you can do it, what is one way that you could attempt to find the 2 answers for a quadratic that we've done tonight? You see the quadratic staring at you? It says solve, get the answers. What technique, process could you apply if you can? Yes?
Factoring in quadratic formula.
Beautiful. Factor. And he's exactly right. If you prefer, or if it will not factor, we saw this earlier, you could do this. You use quadratic formula. Now, since I'm closing down, if you guys have something to do for me, there's some other techniques. Besides factoring a quadratic formula, there's other techniques that more than likely you've seen, but you may have forgotten, that might give you those 2 answers for that quadratic. Can anyone recall any other method which I've not shown you tonight?
Synthetic division.
Not synthetic. I know what you're thinking about, not synthetic.
Completing the square.
Oh, whoa, hold on. Somebody said something. Who was that? Who said that?
Nancy.
Was that you?
Yeah.
Whoa, so I'm gonna put this in a different color. He's telling me, wait, Professor, I remember something called this. Completion of the square. Oh, wow. That's a little bit more demanding. I'm gonna show you how it works though. That's a little bit more demanding. If you apply it, it will give you the 2 answers. A little bit more work though required. And I think there's one more way, which is the easiest of all, to get the 2 answers. And then we'll see who can in this clever class tell me, what do you think I have in mind for a 4th method to find the 2 answers? Factoring? Nah. Quadratic formula? Nah. Completion of the square? No. What else could I turn to help me out to find the 2 answers? Anyone?
Graphing.
Oh, tell me again.
Graphing.
Graphing. Now, can anyone tell me, what are you guaranteed if we were to graph a quadratic? I want to see a picture of what is a quadratic. I know what a quadratic equation looks like, but what does a quadratic itself look like graphed? So first we got to visualize that. Yes,
A
a parabola. So the graph's going to be a parabola. And that parabola can open up or it can open down. But if it's a quadratic and you're graphing, it's going to be one of those shapes. A parabola opening up, parabola opening down. Now, if I were nice as an instructor, and I ask you to solve a quadratic, not factor, don't use quadratic formula. For goodness sake, stay away from completion of the square for right now. But I did this for you on the quiz. I have on the side here a graph, a parabola, as she tells me, that represents the quadratic. Now, I'm going to quickly do one. You say, Professor, like what? It may graph into this. That's a parabola. Now, can anyone tell me? Be clever. Suppose I supply a sketch of the problem. I've graphed it for you. It's going to graph into a parabola if it's a quadratic. And then I ask you, solve it. In other words, tell me the answers. Can anyone tell me, if the graph is staring at you, how are you going to find the answers right quickly if I give the graph to you? And you don't have to do this. You don't have to do this. You need not do this. It's right there in front of you. Where are the 2 answers if the graph is provided where are the two answers for that quadratic located quickly?
You have to look at the points where the parabola sort of crosses the x.
He tells me, he's telling me right now. He says, Professor, if please, on the quiz next Wednesday, please, Professor, graph these for us. Because all I need to do, as he's telling me right now to do, he says, Professor, you better take note of where that parabola crosses the x-axis. Those are the answers. Those are the answers. Now, just to make a little sense of it, we're not going to do anything with this tonight, but I'm leading you into something for next week. He said that perfectly. Now let me label this, just for an example. Suppose this were the ordered pair. I'm going to call it -1. -1, 0. It's on the x-axis. Put my x and y here. And this one, let's say it's out at 4, 0. The answers then automatically would be, what two answers? -1 and 4. Now, where's that 0 come in? What part is it playing? Did we always set this equal to 0? That's where the 0 comes in down here. So set equal to 0. So as soon as you set 0, which is on the x-axis for us, you got the answers. Please tell me next Wednesday. Would you guys quickly run to rate my professor and say, I have the greatest professor in the world? I have the greatest. Yeah, I'm working on a rate my students. It's going to be released pretty soon. You may want to read some of those comments. But rate my professor, man, he is great. What did he do for me? He graphed it for me. And he showed me where it crosses the x-axis. And I got 100% on my first quiz. Would you like that for the next Wednesday? I'll go ahead and graph it for you and show you where it crosses the x-axis. And Mr. Park and I will both smile. We'll be so happy, right? You have the answers. Now, am I going to do that? No. No. Not on this quiz. Are we going to do it later on? Yes. We have to do it later on. Something because they're going to be asking more than just that. We have to do it later on. But right now, no. But isn't that cute if I would? Now, I guarantee you, when I start scoring papers next Wednesday, I'll sit down and start scoring papers. And I know my students are coming from all different backgrounds, all different levels of math that they've had in the past. Some students, many students I've seen, when I start scoring papers, they will graph. If I just say solve, I love what they're doing though. If I just say solve, some of my students will say, Professor, if you say solve, you didn't tell me how, you didn't say factor, use quadratic formula, you didn't specify how, they quickly graph it. And in their mind, they have it. They have the graph. I love that. They've seen this somewhere before, and they have a graph, and they say, oh, there's the intercepts, x-axis. I've got the answers in no time. So I thought I'd point that out. But guys, in closing down, before I ask you to do something for me tonight, let me try, let's see if I can. We've got a lot of work tonight. Completion of the square. To close down, just to give you a glimpse of what's going to happen here. I'm going to go back to this. We were asked, I think, earlier to solve this equation. It's a quadratic. X squared subtract 4x is equal to 12. In fact, I don't know, do I have it here somewhere on the board? Oh, right here it is. We've already done it. We've already done it. Mr. Professor, repeating yourself. Right? I'm just repeating myself. What's wrong with you, Professor? You've already done the problem. What are you going to do? I'm going to do it with a different technique. Now, shouldn't I get the two answers again? Same two answers? Now, a different technique. This is called completion of the square. First, let me ask you, would you accept this for a start? Is that, which we have answers for over there, is that equivalent to this? Then I need a good response. Beautiful. Please tell me, and I can see right now the way you're looking at this board, this is a clever class. Please tell me, is this quadratic? This quadratic that we factored and found the two answers. We have the two answers, we have solved already. But is equivalent to this? Are these two the same, just written differently? And how would I check to see is this just another version of this? Are they actually the same? Now I'm gonna do this right quickly for you. Can anyone tell me, no, just check and see if they are the same first. If you expand this out, guys, what is x subtract 2 times x subtract 2 to begin with? X subtract 2 times x subtract 2 back in Algebra 1, probably maybe 4, is what if you multiply the two factors together? X squared, there you go, minus 4x plus 4. X subtract 2 times x subtract 2 is that. And of course on the other side, I still have that equal to what? 16. Please tell me, if I should move this over, would that now leave me x squared subtract 4x is equal to, subtract 4, 16 subtract 4 gives me a 12. Is that what I originally had here? Is that the original?
Yes.
And I had, now, is this the same then? Are they the same? I checked it. Is that true? Now, suppose you now recognize that I could rewrite that as I did. X subtract 2 squared is equal to 16. Could I now say, wait, Professor, if these two are equivalent, I would prefer to solve it here. Maybe my factoring skills back there are weak. I'd prefer to finish it up right here. How? Some students love this. Put it in that form and then do what? Introduce a square root on both sides. The square root of the left-hand side, what's the square root of x subtract 2 squared? It's merely x subtract 2. Right-hand side, what's the square root of 16? 4. Now, the catch is, though, how many answers am I expecting when I finally finish up? 2. So this is where we put plus minus to ensure we get 2 answers. So I just merely introduce the square root on both sides, make plus minus to ensure I get 2 answers. Now what is x? I isolate the x, move the 2 over. Now you got 2 plus 4, which is 6. 2 minus 4, negative 2. You got them combined. And by the way, were those the same answers I had back here? Was it 6 and negative 2? Same answers?
Yes.
Now, as you go into a calc class, I love calculus. I like free calculus. A lot of my colleagues who are now teaching calculus this semester are telling me, oops, I gave my class a little diagnostic test the first day, Ramsey. I thought I was talking to some of them today. I said, how's it do? Want to have a good group to work with? Not much response. And all they were asking was some things like we're doing right now in pre-calc, this class. Now, please tell me, if you can change this into this, might it be easier to finish up and do a square root on both sides and get the answers? Or, if you say, no, Professor, I'd prefer to leave it like this, like we did over here, and factor directly and get the answers. Did I get the same answers, though?
Yes.
Now, to close down, oh boy, we had a good class tonight. Can anyone tell me, as we do close down, how on earth did I, as a professor, how did I know that that is equivalent to this? How on earth would I know? Hang on, I'll just change it a little bit here. X squared subtract 4x, beautiful, plus 4 equals 16, 12. And we got 12 plus 4 here. How did I know that I could do that? 12 plus 4 is 16. How did I know? Looking at this, this is the original. How did I know to maybe do something like that? That I could change it? And I heard the phrase is completion of the square. And did I actually have a square to work with eventually in there? But how did I get to that point? Am I just smart? And I knew it looks like that? If I wish, I can rewrite it? Or was there some little process maybe I should use to make sure I can rewrite it in that form? That's the question that we're sort of in with tonight, yeah.
I think because the square originally is not completed because it's left in x squared
Hang on.
minus 4.
Love, hang on. She's saying, Professor, you got x squared minus 4x. She said, I love what she said. She says it's not quite complete. In other words, there's something missing.
Yeah. Which is 4.
Ah, she says a 4 is needed to complete that left-hand side, Professor. Oh, by the way, guys, if she does put a 4 there, will all this right here factor into this?
Yes.
X minus 2 squared. So she's making it complete. I love that word. And she's saying complete it by placing a 4. Now, if she places a 4 there to make this equivalent, must also place a 4 on the other side. As you place it on one side, you have got to place it on the other side to keep things balanced. Must that 4 also go over here? So she's asked me to put a 4 on this side to complete it, and also put a 4 on this side to make them equivalent, balanced on both sides. And would that give me x minus 2 squared, like we had, is equal to 12 plus 4? 16. Whoa. Now here goes. I'm going to complete this all the way. Can anyone tell me right quickly? What do you think is needed? I love what she gave me. What do you think is needed here to complete this one? She gave me a 4 to add to each side to complete the last one. What do you think? It's a magic number? What do you think it's required here to complete it here? Now be careful. Yes. Tell me again. 3? Oh, close. Oh, close. I see how you guys got 3. Not close.
9.
9. Now, if I place a 9 first, I'm going to place a 9, then we're going to close down with y and 9. Here we go. X squared subtract 6x. I'm here to complete this, Professor, at a 9. Of course, if I do it there, I must do it on the other side. Now, when I say complete, that word she's using, by adding 9, what does that left-hand side now look like? Does it look like this? Now it's x squared subtract 6x plus 9, so it took a 9 to make that happen. Of course, the other side is what, 16? And you can apply a square root, and you're on your way, you got the answers. Now, nice. Oh, what a class. I am so glad you're recording this. Mr. Park, you are recording this, aren't you? This guy, all of a sudden I turn over here, he's doing coding and AI and all that business. Jeez. Okay, here's where we're gonna close down. Who would like to be exempt from the quiz next Wednesday? You only have to show up for the quiz, so it's just going to give you 10 points to you. Wouldn't that be nice to have an exemption? Exempt. I'm so smart, Professor Ramsey says I won't take the first quiz. He's just going to give me a 10 on the first quiz. Oh boy, I gotta be careful though. Now I want to know to close down. What's the number to complete this one? That's where we're going to close now. First one's a 4. The other one's a 9. This one. Did we get? 3. 3.
Nice.
Go for it.
It would be half of 2, but you take the 3 out, but then you're gonna have to multiply the 3 back into it.
Love this. Go ahead.
And then
So what's your final number you're going to place on the end? like we placed a 4, we placed a 9. To complete it, what is it gonna be for that number? Love this. Love this. Go up, say the hand go up.
Six.
What's that?
It'll be 15.
16?
15.
No, no. This one's tougher. This, what's the hand going up? Let's
What's
see.
the answer for x equals?
No, not x equals, I just wanna know what number should I place on the end? Like I placed a 4 on this one, and on the one other one, I may have erased it, no I didn't, a 9. I want to know what, on this one should I be placing on the end? And no one's answered it yet.
Is it a big number or a small number?
It's a small number.
Oh.
Yes,
One.
not 1.
Is that like 4 over 9?
Say it again.
4 over 9?
Let me try and look at it myself. Nope. You're sure on the right track.
Oh, thank you.
And you were on the right track.
Is it 1/3?
1/3?
1/3.
Close.
2/3.
Yeah, I better get that. No one's gonna make the same for the quiz, be here. Next Wednesday. Be here. No one- yeah. But, before I close down, does anyone think they know before I close down? Another guess? I looked at it right quickly, and this is where we'll start class on Monday with you guys. I think, Mr. Park, help me out. I think I'm doing my math here. Yeah, I think it is. What do you think it is eventually I'm gonna place on the end? On this one, I placed a 4 on the end of one of these quadratics, I placed a 9, my students were giving me those answers just like that. And now I wanna know what might I eventually place on the end of this one, and it's tougher.
Holy.
Of all the numbers in the universe, there's lots of them, there's only one.
Is ChatGPT?
No. Okay, guys, I'll leave some time to add my students tonight. So I'm gonna let you go. Now, should I tell you what it is?
Yes.
You may have to figure out how to get it. I think it's 1/9.
1/9.
Ooh. You said 4/9.
Yeah, that's close.
I think it's a 1/9 involved there. You were very close also. You were very close.